Hello, welcome to lesson 4 in unit 7, right triangles. Today we're going to be talking about trigonometry. So we're going to be introducing trigonometry. It's a little bit different kind of math, but I think you guys should have a pretty easy time with it. Um, so the essential question is, how do you determine whether to use trigonometry or inverse trigonometry? So that's what we're going to be talking about in today's lesson. So far, we have learned two ways to solve for missing lengths of the sides of a right triangle. So on day 1, if you recall, we used proportions when we set up our chart to solve. So lesson 1, we used proportions to find the missing lengths of the sides of a right triangle. And then in day 2, we used Pythagorean theorem to solve for the missing sides. Now today, the third way we're going to learn, this is something that you're going to want to commit to memory over this unit, is what's known as SOH, S-O-H, C-A-H, TOA, T-O-A. Now this is an abbreviation for what we're going to be using in trigonometry. The S stands for sine, O is opposite side, H is hypotenuse. The C stands for cosine, A is the adjacent side, H is the hypotenuse again. And then T is tangent, O is opposite side, and A is adjacent side. So that should make a little bit more sense in a minute. So we're going to use SOHCAHTOA when we're talking about right triangles. So the first question it asks us here, if we're looking at this right triangle, is which is the hypotenuse? Okay. So if we look at our diagram, we see that the right angle is at C. Across from it is the hypotenuse. So the hypotenuse is AB. Now, it tells us under that to focus on two different angles, and it asks us two questions about each angle. So first, it says with respect to angle A. So we're going to first look at angle A. Okay. Now, when it says, now the first question is which is the opposite side? So which side is opposite angle A? So if you look across from it, opposite from it, is side CB. Then it asks what side is adjacent to angle A. So there's two sides left. Hold on one second. Okay, so for the adjacent side, there are two sides left to choose from. So we got AC or AB. But if we look back at the first question, we already said that AB is the hypotenuse. So it can't be AB. So when we're talking about adjacent sides, we're talking about sides that touch the angle, share the angle. So then our only other option is side AC. Okay. So that's it for that one. Now the second part, it tells us to look with respect to angle B. So we're going to have the same hypotenuse, but the other two questions are going to change a little bit. So now we're focusing on angle B. And it says which side is opposite. So we go across from it. So we got now AC is opposite. Okay. Again, it asks us which side is adjacent. And again, we already said that AB is the hypotenuse. So it can't be AB. So that just leaves CB. And also CB has angle B in the name. It's touching angle B, it shares angle B. So that's how you figure out which side is the adjacent side. Okay. Now you go ahead and do the next two problems below. It's actually asking you to do the same thing. There are two angles in each example. So go ahead and complete that, and I'm going to move on to the next slide. Okay, so now we're coming back to what I introduced in the beginning, SOHCAHTOA. So you can see from the diagram here that so sine of angle A. So that means we're focusing on angle A. Because if you remember, when we talked about opposite and adjacent sides, it changed depending on what angle we were talking about. So if we're talking about angle A, sine is the length of the leg opposite angle A. So however long the side opposite angle A is, over, so we're going to have a fraction, the length of the hypotenuse, which is C. So our fraction is going to be side A over side C. For the cosine of angle A, we're going to have the length of the adjacent side, which is side B in our diagram, over the length of the hypotenuse again. So hypotenuse goes into the denominator. And then for tangent of angle A, we're going to have the length of the leg opposite angle A. So side A is over the length of the leg adjacent to angle A, which is side B in our diagram. So in the future examples, or in the problems, you're going to have numbers for the sides of the triangle, and that's what you're going to plug into the fraction. So now the easy way for you to remember this is SOHCAHTOA. Okay? And that's just sine, again, is opposite over hypotenuse. So that's how we're going to remember that. Ca is cosine is adjacent over hypotenuse. So this is kind of the same thing that we got up in the example diagram, but we're shortening it a little bit. And then TOA is tangent, which is opposite. Oops. Acting up, but it's back. It's opposite over adjacent. So this is the same thing we have above, but we're just shortening it to just the first letters. So we got SOHCAHTOA. We're gonna remember that for this, the rest of this unit, because it's gonna be helpful. Okay. Now we have an example here. Find the sine, cosine, and the tangent of the indicated angle. Okay. So if you've been noticing, we're never going to do the sine, cosine, and tangent of the right angle. We're always using the two acute angles in the triangle and not the right angle. So the first one asks about angle S, so we're going to be focusing on angle S. Okay. Now, it asks to find the sine first, so we're going to do sine. And if you remember, sine was opposite over hypotenuse. So if we look at the diagram, we know that the hypotenuse is going to be the biggest side and the side across from the right angle. So the hypotenuse is 13. And this is the only one we're going to label, because the opposite and the adjacent changes depending on which angle you're talking about. So we're just going to label the hypotenuse for now. Okay. So if we go back to the question, we got sine is opposite over hypotenuse. Now we just got to figure out which side is opposite of S. So if we look at the diagram, 5 is opposite. So our fraction is going to be opposite 5 over the hypotenuse, which we've already said is 13. And that's our fraction. Now it asks us to find the cosine, SOHCAHTOA, which is adjacent over hypotenuse. Okay. Now, we already know the hypotenuse is 13, So the adjacent side is the other side that's sharing or touching angle S. So we got 12. So it's going to be 12 over 13. Finally, we got the tangent, so TOA, opposite over adjacent. Now we already said what the opposite is in the sign, so we know the opposite is 5. And we said what the adjacent is in the cosine, so we know the adjacent side is 12. And that's all it is. And of course, if you have fractions that can be simplified, please do. But we're pretty much just saying which sides go with sine, cosine, and tangent. So for angle R, we can do the same thing. So now we're talking about angle R. Again, we got sine, opposite over hypotenuse. Okay. We already know the hypotenuse is 13. Now, for when you're talking about angle R, the fraction is going to change a little bit because the side opposite of angle R is not 5 like it was in the first one, but it's 12. So the sine of angle R is 12 over 13. Then we got cosine, adjacent over hypotenuse. That's going to be, hypotenuse is 13. Okay. Now the side that shares angle R is this side, RT, which is 5. And finally we have tangent, which is opposite over adjacent. We already know the opposite side is 12, and we know that the adjacent side is 5. So we got 12 over 5. So the only really, not even tricky, but the only thing to watch out for is that when you're talking about different angles, the fractions change a little bit. So the opposite side is going to change, and then the adjacent side is going to change. But the hypotenuse is going to stay the same. So that's just something to watch out for. Now you got 3 problems at the bottom of this page that you can practice on. You're going to want to find the sine and cosine for sine, cosine, tangent for two angles in each one. So for the first one, you're going to find sine, cosine, and tangent for angle S and for angle R. So I'll give you a couple minutes to figure that out. And I'm going to move on to the next slide.